COP26's ambitious goal of 100% zero emission vehicle sales by 2040 may hit a roadblock before it takes off. The repercussions of stalled production and manufacturing lines has sent lithium, nickel, and cobalt prices soaring, putting the brakes on EV sales. Has the electric vehicle movement stalled? Well, as it turns out, not at all, although there are some issues we will need to address along the way. Welcome to the session, Reality Check, Battery Metals and the Challenges of Electrifying Transport. Here to talk about our realities and how we move forward is Roman Kramarchuk of S&P Global Platts. With years of experience in the energy sector, he joins us to discuss the realities of our energy transition. Roman, thanks for joining me here at EBPowerCon. I'm really looking forward to this conversation. Now, I should remind the audience, right here at the outset, that really the electrification of anything is good for an audience of electrical professionals. So in case anyone out there is wondering, this is not a conversation about halting electrification or electrifying transport or what have you, but rather examining what is realistic now, what constraints and obstacles do we face, and what is realistic in the near future. So Roman, again, thanks so much for joining me.
Thank you. Thank you for having me.
Now, Roman, before we get deeper into the nuts and bolts of our conversation and some of the stats and figures that you and your team have, maybe help set the stage for us, because while we were chatting earlier, you were at the recent COP26. So why the call for 100% zero emission vehicles by 2040 in the first place? Help set the stage.
No, sure thing. I think it's really a call for decarbonization, and that was the impetus. That was really the driver at COP. Certainly, there are concerns about smog and soot and other pollutants that come from transport, but the primary driver here are really greenhouse gases. Now, at Platts Analytics, we have long-term energy modeling tools. We have a global integrated energy model where we develop a reference case, 2-degree case, and other cases. And what that shows is really global greenhouse gases peaking this decade and then going down slowly. That's our reference case. But a 2-degree case will need emissions to be 50% lower than our reference case by 2040 and 2050. Net zero cases are even more dramatic. So where does that bring us in terms of transportation, power sector, and other sectors? In our modeling, the emissions from passenger vehicles account for 11% of the total emissions from CO2. Emissions from other transportation, non-bunkers, account for another 13%, and that can be like commercial vehicles, trucks burning diesel, and et cetera. So, those sectors need to be decarbonized because a number of other key sectors are that much harder to decarbonize. Basically, we're looking at key sectors like the power sector, which we have and we know what the solutions are. There are tools in the toolbox to decarbonize that sector. In many ways, for passenger vehicles, electricity is the accepted approach. It is the tool in our toolbox to get electric vehicles down to low emissions and potentially zero emissions. We have the technology and we know how to do it. There is a little bit more question around heavy-duty long-haul trucks. I think for shorter haul trucks, for buses, once again, electricity is seen as the viable solution because you have shorter distances, you have less need for weight. For heavy duty long haul trucks, where every pound that you carry matters, heavy battery packs are more challenging. And that's not to say that electricity is not in the running, it certainly is, but the jury is still out. And I know we're talking about electricity, but hydrogen is in play for heavy duty long haul trucks. And how long haul we have to talk, that's one of the things that when we look at technologies and how they develop, that's what we're going to be looking at. So in terms of what we're looking at, I want to come back to our reference case. In terms of global statistics, in terms of percentages of sales, well, we saw EVs account for a little less than 5% of total sales in 2020. In our reference case, note this is not our 2-degree case. This is not our net zero case. In our reference case, by 2040, we expect EVs to account for over 50% of total sales and account for about 30% of the total EV fleet. that's and if you split that up, it really depends where. We have by 2040 in the EU, 75% of the fleet will be actually would be electric, and when we're talking about the US, it would be closer to 35%. But these are all data that flow out of our modeling. The interesting thing about COP is there was a transport day at COP26. And that was the big announcement that you noted. This is the fact that businesses and governments declared that and committed to new passenger cars and vans being 100% zero emissions, no later than 2035 in leading markets, and then the rest of the world would follow by 2040. Now, this was a big deal. 30 national governments, including the UK, Canada, India, Poland, did sign along with specific automakers such as Ford, GM, Volkswagen. But, and there's always a but here, the largest auto manufacturing countries, including Japan, the United States, Germany, and China, were all absent from that agreement, as well as companies such as Toyota. So, one can point to the achievements and the commitments that were made on Transport Day, but one also has to be cognizant of the fact that there were plenty of important players that did not sign on that dotted line. It's not to say that they're not committed. It's not to say that they're not on board with other policy targets to actually advance electrification of transport. But it just means that on this particular one, with this particular deadline, this isn't something that they felt comfortable signing on board. And automakers are major employers. Automakers are major contributors to the economies of these countries. So one can expect that the pace at which automakers feel comfortable about this change is one that the countries themselves will take into account.
Interesting, and I'm glad you raised that distinction that just because they weren't at the table signing along with these other players doesn't necessarily mean that they don't have plans or other things that they are trying to achieve. So we shouldn't write them off, as you say. So thank you for bringing that up. Now I'd like to get to talking about, because we are on the subject of electric vehicles. So let's get into some of the facts and figures from S&P Global Platts, which looked at the price of battery metals. So Platts estimates the battery costs, which typically constitute 25% to 30% of electric vehicle costs, could soon comprise 50% of the overall cost of a new electric vehicle. Now, just for the audience, I did a comparison about 2 years ago now, so a little dated, between a Chevrolet Spark, which is a regular fuel vehicle, and the closest equivalent I could find, which was the Chevy Bolt. Now, at that time, 2 years ago, the MSRP for the Spark was $19,298. So rounded off, just call it 19,000. While the MSRP for the Bolt, the electric vehicle, was 45,918. So rounded up or rounded off, we're looking at 46,000. And these prices came straight from General Motors' website. Now, these are small vehicles, tiny little compacts. I think the smallest you can find, at least on Chevrolet's site. So how does the Platts analysis play out against these facts, considering the cost disparity between these two vehicle types? What impact will the price of these battery metals have on the average consumer?
No, I mean, clearly this is a big issue. If if EVs had been cost competitive, people would have been buying them, manufacturers would have been manufacturing them, and we would be well on our way. The fact is that battery costs do make up a significant portion of the overall cost of the electric vehicle. That is the major difference. When you're looking, it's the drivetrain. I mean, certainly there are some savings, with other systems, but it's the overall cost of that battery. And the thing to keep in mind is that cost of that battery has been dropping pretty precipitously. And when we think about technologies for the energy transition, we think about things like solar PVs, we think about wind turbine prices, but batteries are in that same category where the costs have been coming down precipitously. And every year we have been seeing cost declines. And that's why this narrative that we're talking about now is a little different. It's one that's worth talking about because historically, we did mention that batteries cost constituted 25 to 30%. And if we then dig down, and we have dug down into what makes up the components of that battery. Well, we have the materials, which make up around 40% of the total battery cost, followed by purchased items, pack integration, cabling, etc. And of the materials costs, about a third of that cost comes from key metals. And by key metals, I mean metals like lithium, nickel, and cobalt. So, when you think about it, that's already not as directly impacting, because you're talking about materials accounting for about 40% of the battery cost. And then of those materials, about a third come from those key metals. Now, to be sure, those key metals have been going crazy. The markets for that have been, multiples of what they were. We're looking at lithium, cobalt, lithium carbonate, lithium hydroxide, cobalt, and nickel. Since early 2021, Platts lithium carbonate CAF North Asia prices, which are a proxy for what might go into a Chinese process, rose almost 550%. Lithium hydroxide, 320%. Spodumene concentrate used for conversion, 588%. So these are reflecting incredible tightness in these markets. These are ratcheting it up. What used to be a smaller share of the total cost to significantly to higher levels. Now, it's also bounded by what I mentioned before. So you're still bounded by the fact that materials are 40% and a third of those metals. But that third of the 40% has really skyrocketed. Now, what does that mean? In some ways, there are different battery chemistries. There are battery chemistries that can focus more on, let's say, use less cobalt or use more nickel. I mean, the common denominator, and this is why they're called lithium ion batteries, is the lithium. And you can't run away from the fact that lithium prices are way, way up. So that being the case, what we've always thought is the materials will be the materials. Those will be the commodities that will feed the prices. The non-materials cost should come down. This is another one of these sort of learning by doing type things. So all of the production processes, as you get experience, the common aspects, these should support cross-application learning with more widely shared benefits. So there is real concern about those materials and those metals. So, one of them is the cost. I just mentioned all the issues around cost. Another big concern is not just the cost. It's, there's a point at which is it available? It's no longer an issue of what am I willing to pay for it, but can I even get it? And this is why some of the automakers are now looking to basically lock in some of their supply chains and almost branch out and make sure that they can assure the reliability of supply. Because, at a certain point in time, it's not how much does it cost, but can I even get it on the market? And the problem here is that, in some ways, there has been a lack of investment in the previous few years. What you had lithium prices drop. And as a result, very little investment came in. There was a bit of a death valley of investment where prices were low, and the thing that one has to realize is that battery capacity, the need and the desire to build those batteries, can be built up much faster than lithium projects upstream. That entire upstream process, maybe not so much the conversion, but if you're going all the way upstream to mining the lithium, either through brine or through rock, these take years. And we are already expecting that this sort of tightness in the markets, we don't expect it to be alleviated this year. There's more hope for some of the other metals, but for lithium, there's going to need to be investment. And even when we look at all the projects that are out there, you almost need a best case scenario for everything to go right for supply and demand to balance. And so I don't want to say that we're going to have supply limiting the potential for EVs, for EV uptake, but that there is a prospect of that, and that's something we're watching closely, because everyone likes to think about, okay, we'll set a target, we will provide subsidies, but it doesn't matter what target you set or what subsidies you provide if you can't get the base minerals enough to meet all the battery needs. So, when we look at what this means, what these prices mean, we do make that distinction. We look at the EU, for example, where the standards are very strict. And it's the manufacturers that if they don't meet the standards, they're on the hook. So in some sense, this is a challenge for the manufacturers, and this is why some of the European manufacturers have really been at the forefront of making sure that they can ensure the supply chains. When you have in China, you have the new energy vehicle requirements. There, it's a combination because there's different definitions of what can get credits, and there's an ability to do so. In the United States, you have zero ZEV vehicle standards, and that's at least 17 states have considered or have adopted those ZEV standards. But then there's plenty of states that haven't. And this is where we use what we call a total cost of ownership model here, because that really says that people will start choosing electric vehicles when you look at the total cost of ownership. You look at whatever extra you may be paying for the car, but you will also look at the savings you get on the fuel side. So you look at the fact that you will need less maintenance. You look at the fact that gasoline prices or diesel prices will be very high. And this is where into that model, we also do feature oil prices, gasoline prices, and overall energy prices, because power prices can be high as well. And it's that power that will be charging that will be charging the automobile. So in that total cost of ownership world, there's a lot of different factors at play, and that's where we see some of the pushback when you start seeing battery prices perhaps not decline as quickly as you thought, or maybe even stabilize and cause that difference between total cost of ownership of an EV and an ICE to start changing. Now, to be sure, as I mentioned, oil prices are important here. So whatever, we're also looking at what's going on with Brent. We're also looking to see what's going on with gasoline and diesel prices, because that's part of your total cost of ownership. And that when those start spiking, people start looking at EVs. So all in all, I mean, what this means is that when we do see increases in battery storage costs, when we do see increases in battery metals, we do adopt and we adopt that into our model, and we do adjust what we expect in terms of expected EV sales and uptake. So for example, even a 5% increase in total battery storage costs run through our model means that we reduce our 2030 EV sales by around 230,000 units. So it all comes through. Part of it is policy driven, and it makes policies more expensive for those that want guaranteed EV penetration. For those jurisdictions that want to incentivize it, but want to leave things up to the market and leave things up to total cost of ownership, relative increases in cost of electric vehicles just means less of those vehicles will be sold. So.
Well, I am pleased that you bring up total cost of ownership, because being in the built environment, there is, or there could be the sticker shock of various new technologies, various new systems. But then you're invited to look at the total cost of ownership, not just, okay, what am I paying today, but what will I be paying 5 years from now, 10 years from now? So I think that's a fair equalizer that you bring into the conversation. One question before we leave, this section, if you will, on electric vehicles, but the energy storage market, because there's talk of microgrids and having more energy storage online for intermittent renewables. Are you seeing pressures from the energy storage market on those battery materials?
I mean, certainly. And we actually do spend time. We have we have other people on our team that really focus on that battery storage market. The thing is, the battery storage market for power for stationary storage has actually been a beneficiary of the EV market, because what you've seen is a massive decline in costs for lithium-ion batteries. But the fact is, the usage of battery storage for the power sector is different, and its sort of use cases are different than you would have for transportation. The first thing to note is that you don't have to have this sort of massive energy density issue. You don't have to have a very compact battery that doesn't weigh a lot. All these parameters that make it so challenging to put a battery in a car. If you can drop a battery on a piece of land, and it doesn't matter how big it is and how much it weighs, it's a whole other set of parameters. So you will not necessarily have the same technologies, the same chemistries, because you don't have the same parameters in terms of need for density, need for volume, for weight of energy. So you'll have a whole slew of different types of batteries that may be available. Now, to date, that stationary energy storage has been a beneficiary, and they've taken advantage of the fact that actually conventional lithium-ion batteries that are used in automobiles have dropped down in cost a lot. But that doesn't mean that you have to go with those chemistries, because, as I said, the power side has a lot more flexibilities. And to be sure, if you look at the relative sizes of those markets, it's it's vastly, the EV part of it is a much bigger component, and it's a more high value component right now. So I guess that, if there are shortages on the side of some of the materials, we would expect that it would actually be probably the power side stationary storage part of the market that may be at the end of the tail there and actually see the impacts the hardest. So
End of the tail. I like that. But to your point, they don't necessarily need to design the perfect battery to fit into the perfect trim or profile of a vehicle. If, as you say, they can just, put it in a container or something on a plot of land, and there you go. Now, continuing with some of the findings that we're referencing here from S&P Global Platts. Now, this was looking specifically at the U.S., but Canada isn't so different. Now, the US alone is projected to have 21 million electric vehicles on the road by 2030, and these will require between 1.4 to 2.1 million charging ports, charging stations in the next 8 years. But in the US today, there's only about 120,000 available. So Canada being similar, smaller population, but similar to the United States, a massive build out of infrastructure is required across North America. What sort of infrastructure, what sort of time and investments do you see that we need here in North America to accommodate the desired number of electric vehicles?
no, it's a valid point. And on the supply side, we do see different vectors of constraints on EV uptake. We just talked about one, which is the upstream supply chain around metals and batteries. But another one is whether EVs will cross the barrier of convenience of use. It's that's the choice. I think there's a portion of the population that's worried about, well, I know how to use my internal combustion engine. I know what I get. I know I can rely on it. And so a key element of that, at least, can be addressed through charging infrastructure. And that's one of the data points that we've been talking about. I mean, the majority of EV charging does currently take place at home. So, what we're talking about is we need further growth. And if we want to have people comfortable with with EV uptake, we need to have people to see public growth in public charging points. So we want to have that expanded access to individuals who don't have private driveways or garages. So that, there's got to be focus on people who are in apartment buildings, who are in cities. We want to also reduce those range anxiety fears. So, and I have the data for Canada as well, but for 2017 to 2020, we saw public EV charging points in the US grow annually by 30% year on year. So this is real growth. At the same time, this is nowhere close to what we're seeing in Europe or China. I mean, China is absolutely leading the world by several layers of magnitude in terms of EV charging stations. So, I mean, in North America, at least in the US, we had the Biden administration have a target of adding 500,000 public charging points through a combination of grant incentives and others. And in November, we actually saw Congress pass the $1.2 trillion Infrastructure Investment and Jobs Bill Act. So as you go through all of the different line items of what was in that 1.2 trillion, you come to 7.5 billion for expanding the number of public charging points. So that's not a trivial number. I mean, if you look at what the Biden administration wanted, they wanted 500,000 public charging points by 2030. This isn't, this would go a ways. This actually would not go to the sort of ratios that we would expect would be needed, but it would make progress towards that front. And what we see in the infrastructure bill is about half of that being passed. So it is a big step in that direction. It won't be enough, at least not for the United States. And so it just means that there are many other tools and other incentives that will need to be set up. And part of that will have to come from the private sector as well. So we have, we got 7.5 billion out of that front. There's two different parts to it. You have 2.5 billion going through state and local governments and other public sector entities, and then you have essentially a formula trading program that also will look at these things. And what they'll do is they'll look to build up investments along alternative fuel corridors. I think that's a common approach that I think we see across North America and Canada and in the United States. And there's work has already been started on a lot of those things. So that's on the federal side. And then I always like to think about the state side. And when we think about states, we look at California, which whose budget would essentially be the budget of most countries in the world. California, we just saw this month, California proposed to be spending 6.1 billion on electric vehicle initiatives for their upcoming state budget. And California has mechanisms through which they can fund this. I mean, for example, they have the California Cap and Trade Program, which is actually one that they share with Quebec. So, entities like California and Quebec do have a revenue source by auctioning off their allowances in their cap and trade program. So there is a source of revenue which allows them to then decide how to spend that money. If we think about what they're looking to do, they're going to be looking to overcome, like I mentioned, some of those issues about multi-dwelling homes and apartments. There's also, we also want the right balance in terms of speed of charging. Do we have enough fast and ultra fast charging networks? Do we want to be having the infrastructure for commercial trucks and vans? And do we also want to think about, and this is part of the equation, is really understanding how this will play out in, let's say, underserved communities, and whether the entire country is coming along the ride. Because as we know, one of the criticisms levied against some of the subsidies that have been provided for electric vehicles so far has been that it's been subsidizing expensive cars for people who can afford them. So that's part of the mantra that also has to be overcome here. So I think all of these things are part of the factors that we look at in terms of the infrastructure needed. I think that's just on the infrastructure side when we think about what needs to be, charging and what we need to have on the ground for EVs to have people be able to overcome their concerns about how quickly they can charge and about range anxiety. There's a whole other side about how this will all fit into the power sector, and maybe that's the next topic for us to discuss.
So moving on, segueing nicely into the next thing that I wanted to bring up with you. So we were talking about charging stations and where we need them. Figuring out how we tackle those multi-use residential buildings as opposed to someone who can charge in their driveway or in their garage. But now let's take a step back and look at the electrons that we need to generate to feed this fuel switch if we want to move to electrified transport. So what sort of investments are required in our own electricity generating capabilities and transmission distribution capabilities to really realize electrified transport in North America?
I think, in some ways I turn that around a little bit because it'll help answer the question. Because it's not that the policy goal or that the societal goal should be to achieve fully electrified transport. What we want to do is we want to achieve fully decarbonized transport. So that goes to the point that I think you're making as well, is that the strong justification for EVs is that the power that they charge with has to be clean. So what you need to have a parallel effort where you need to invest so that the grid is green. I think Canada is particularly blessed in this area because in terms relative to a lot of other countries, the relative share of very low carbon or zero carbon electricity is very high. That's in most provinces, I think, and in those provinces where there still is, let's say, coal or natural gas fired generation, particularly the coal fired generation, it is being phased out. That's not necessarily the case in many other parts of the world, and that's why in some ways Canada has a particularly strong case for pushing for electrification, because that electricity really is green, much more so than other parts of the world. And in terms of what's needed, once again, I'll come back to the US. We are expecting 21 million light duty electric vehicles on US roads by 2030. And that's adding, we calculate 68 terawatt hours of incremental power load to the US grid. So by 2040, that 68 terawatt hours goes up to 300 terawatt hours. And for reference, 2020 US power demand was less than 4,000 terawatt hours. So, by 2040, we're talking about nearly 10% of current power demand would be from electric vehicles. And EVs become a key part of the electricity story then, along with hydrogen electrolysis, along with electrification of residential commercial heating. Um, they will be part of the grid, but there will need to be investment. And part of the investment will need to be addressing the incremental part of it. Part of it will be to ensure that that grid is green. And I think all of these things have to be considered. The other part of it, and this goes back a little bit to the prior conversation, is also the challenges of the convenience. I think, and this is kind of where the the transport world and the power world really need to talk to each other. And it's about DC fast charging. It's you can have level 1 charging for cars that that where you have about, those are rated 1 to 3 kilowatts. Level 2 up to 20 kilowatts, DC fast charging, going already up to 200, et cetera kilowatts. But when we get to something like fast charging trucks, there is a new initiative that essentially talks about developing fast chargers of 3.7, 3.75 megawatts for a charger. Now, just, think about what that means for a power system. If you're going to be charging a single truck, and that single truck is going to be putting a drain of 3.75 megawatts on the grid at a single point in time. What this just really points out to, is that you'll have one truck accounting for the same amount of energy as a few thousand homes at an instant. So what this really means is that this will need to really be integrated. It will need to be priced appropriately. The engineering will have to be figured out, and the pricing will have to be figured out. Because if you need to build infrastructure, if you need to build capacity, if you need to build storage in order to be able to meet the demand of this fast charging, then that should be priced appropriately. So in some ways, we need to get a better feel for how important that fast charging is. I think right now the push is to make it as convenient as it can be, and to make it convenient so that people feel comfortable around that this is a comparable product to internal combustion engines. It's one thing if you will have on-demand charging of, let's say, very major large trucks, and it's another thing when you have EVs become part of the broader grid. And I think that's one of the very interesting pieces of this. Ultimately, what you have is you have batteries that can charge, and if you give the opportunity for those batteries to charge, let's say when you need them, when you need some power for ancillary services, when you can take advantage of arbitrage opportunities. Ultimately, on the one hand, what you can control the charging side, but ultimately you can have what you call V2G, which is vehicle to grid, where in some sense you have a fleet of cars and the grid talking to each other and providing essentially the services and optimizing over the broader system. And we've done a number of these long-term studies. We just completed one for Europe, and we've done them in the United States. When you go into a world where renewables and intermittency is so important, then a key element of that puzzle is flexible demand. And we see flexible demand for electric vehicles in key European countries making up 5% of total demand. So this is now an integrated part that if you need to make up fluctuations, if you need to make up either on a very short-term basis or even in terms of longer-term arbitrage. Now, not suggesting that obviously people buy cars so they can drive, not so that they can help seasonal storage concerns with the utility. But on a regular basis, on a day-to-day basis, there is the opportunity for those EVs to become part of the grid. And once again, for that to happen, you need to have the infrastructure, and you also need to have the markets and the pricing in place so that people realize and can make those decisions. And then you can really get that optimized grid, because intermittency can cause a lot of stresses on the system. When we think about what can help address those intermittency concerns, flexible demand is certainly one of them. Energy storage is another one. I mean, these are all pieces of the puzzle, and peaking units are another one. These are all pieces of the puzzle that allow the grid to balance. And by 2050, we see EVs, being one of those key role players for that purpose.
So sort of to sum it all up, basically, can we afford it? Can the supply chain keep up? What is actually realistic? And by the sounds of it, based on your studies and based on the technologies and movements that you're following, it does sound realistic. And I detect a real positive note that it is coming. Now, whether it's going to be 2050 or 2055 or 2047, would you agree that it is coming?
Oh no, it is certainly it's coming. And in our mind, I mean, when we think about our reference case, that the thing to remember is our reference case is not our 2-degree case. And our reference case only gets emissions, flattened and starting to come down a little bit. If we really want to get to a 2-degree case, we have to cut that reference case emissions in half. And that means that our reference case assumption of 50% of EV sales by 2040 is not enough. So, if anything, we are building in a massive uptake of electric vehicles in our reference case. That is going to present challenges already, but in other ways, that's not enough. If that's not enough, if you listen to, if you go to COP, if you listen to what people are saying, a reference case where you have 50% EV sales globally by 2040 is not enough. So I think there are certainly challenges. I think there's challenges around, procurement of some of the materials. There's challenges around infrastructure. I think these are all solvable challenges, and particularly if they are addressed early on, if there's a vision as to where you want to go, and if you provide, like I said, the right incentives, transparency around pricing, and allow the market to make the right decisions. I think the potential is there.
With that potential comes great potential for people involved in the electrical disciplines, because this is and should be all good news to them. So, Roman, thanks so much for joining me here at EBPowerCon, lending your expertise and your knowledge. And it's great to know what is going on globally, so that we're not too focused on just what's in front of us. So I really appreciate you bringing that perspective.
No, thank you. Thank you for having me. This is a great conversation, and we know we could have gone on for another hour, but thank you for the time that we have.